Now on the back page, it's just some review questions. I know it's spring break, after spring break, so you may not remember what's covered back then before spring break. So let me just go ahead and review the stuff very quickly. Okay. Now, when two vectors are parallel, that means they must be a multiple, or they must share the same scale factor for both x and y. And that means, well, if they are sharing the same scale factor, in other words, if you put them into proportion, they must be the same. If you put the x over each other, put the y over each other, they must be the same. That's a relation, that's a key, okay? If they are parallel, they must be proportional. So you can go ahead and find out what it is. So k is equal to negative 27 over 2, or 13.5, negative 13.5. Okay. So make sure you know what to think. Parallel vectors, meaning that they must be proportional, they must share the same scale vector. Now, what if they are perpendicular? Okay. So 2 weeks ago, when we said they are perpendicular, well, cosine of 90 is equal to what? What's cosine of 90? What is cosine of 90? 0. Okay. Cosine of 90 is 0. Now, what is also the definition of a cosine theta? Well, we have two vectors, right? So we have v dot w, so dot product. We talked about dot products before spring break. So v dot w over the magnitude multiplying each other, and that's all equal to 0. And we say if a fraction is equal to 0, that means the numerator must be 0. So we will now go ahead and find out what the dot product is, because the dot product must equal to 0. So we say v dot w is equal to 4 times negative 5. The x will be multiplied together, plus k times 2. The y will be multiplied together, and then we add them all. And they should all equal to 0. So we say, well, negative 20 plus 2k is equal to 0, so k must be 10. Okay, so that's the logic behind this whole process. Cosine 90 is equal to 0. Cosine 90 is a dot product over the product of the magnitudes of the individual vectors. And if that's equal to 0, so the numerator, the dot product, must equal to 0. So we just go ahead and find out the dot product, set it equal to 0. You can find out the k. Okay. And for number 3, now the component form. All right. Now, if you forgot what the component form is, it's this with the I and J. Okay. So a little quiz for yourself would be, can you tell the component form? So for this one, the component form would be negative 9i plus 12j. Again, something down the road in calculus 3 is that we will use matrices to do these vectors. So that's why we want to express these vectors as a little expression like this. All right. And then we have polar form. Now, polar form, it's where the x becomes r cosine theta, I, and then y becomes r sine theta, j. So we will need to find out what the r is, which is the magnitude of the vector, and the theta. So let's go ahead and draw this one out. And we say, right, so this is the vector. So this is -9, this is 12. So can you find out the magnitude here without calculator? If this is 9, this is 12, the hypotenuse must be? The hypotenuse must be 15, because it is a 3, 4, 5 triangle multiplied by 5. Okay. Now you will need to find out this angle here so that you can find out the actual theta. So let's call this theta prime. So tangent of theta prime, it's 12 over 9. So tangent theta prime is 12 over 9. So if you put into your calculator, so theta prime would be an angle of 53.130 degrees. Okay, that's a theta prime. All right, but you want to get the actual theta right here. So so the actual theta would be 180 degrees minus 53.130 degrees, and that is 126.870 degrees. Okay, so that's how you get your theta. So with the r theta, so r it's your 15, and your theta it's 126.87. 126.870 degrees. I, don't forget the I, okay? 15 times sine of 126.870 degrees. J, so for polar form, we will leave the value of R there. We will leave the value of theta there. If you actually compute this part, that will give you -9. You can try it. I would suggest you to try it so that you can see how they're equivalent to each other. Okay, just a different kind of expression. And for C, unit vector, it's simply the x over the magnitude, comma, the y over the magnitude. And then you will simplify this. You will simplify this to -3 over 5, and then 4 over 5. Okay, so that's how you get your unit vector. So make sure you can tell these vector stuff, like express the vectors in different forms. Okay, so that's it for the review.